Hello YouTube, just a interesting build for today. Basically what I got going on here is this laminated iron core, and it's about 3 inches this way and like an inch thick and about 8 or so inches wide, and there's like two U shapes here, right? And this is like 300 windings right here, and this came out of like the mains of a big transformer for I think it was like some sort of single phase transformer. But anyways, I took it apart, and so what I got going is 88 turns of number 20 wire here, and this is 111 turns of number 24 wire. And so essentially this is just kind of acting as a isolated pickup to measure this without affecting it as much. And that's kind of like a semicircular arc. It doesn't go all the way around. So I have it sitting on a skateboard to isolate things from ground with the wood. And nothing's on right now. The Bendini motor is off, and it's just kind of ringing and oscillating, as you can see. And this is the signal that it's kind of putting off right now. So we're currently at 1 millisecond sweep time, which is the divisions per frame. Um, we are also currently at 2 millivolts per division, so pretty small amount of energy, but we're going up to 2 to 3 divisions going up above zero, and then we're at a solid 3 to 4 divisions going down. And this just keeps going. Seems like once it starts ringing, as long as it's not disturbed so far. So this is just my first test. I just built this just for the fun of it today. So what I did, it wasn't doing this initially. What I did is I took this Bendini motor and I thought, what if I just pulse this primary right here with the output of the Bendini motor just to see what happens, because it's got that sharp impulse. And essentially I've like a little blocking diode right here, so it goes out, and then it really lights that up when I turn this on, of course, because it's coming back through and shorting it. I should probably try it with that falling off. It did fall off earlier when I tested it, and it seemed like that both those bulbs really lit up when I did that. And the interesting thing, if I can get it to focus, is that the plasma and the neon bulb over to the right there, it it's mostly like orange, but sometimes it's like purple. And then this current bulb uh, turns on when I start it up, and then also when this falls off. Kind of interesting, but yeah, it's just kind of like oscillating right now, and it kind of has this weird modulation. It's like a cyclical pattern of the noise too. But yeah, I just want to show that. So earlier I didn't have these supercapacitors on here, and so basically I just tested it with a little red LED, took one of these, charged it up with the Bendini motor, flashed it on here, and this red LED flashed. I tried a green LED on this one and nothing happened. Um, so I knew there was energy coming through here, so I'm curious if I captured any energy from turning this on for a couple minutes. So I'm going to see if I can short it and get a spark. See if I can do this with one hand here. Okay. Yeah, So I did get a good spark off of that. So that's pretty cool because this is completely decoupled and it's picking up that much energy of the flux switching through here. So that's cool. And then let's see this other one. This one didn't seem to go. Maybe it didn't have good contact. Not really sure. But here's a waveform. It's not affected by sucking that load out. This is just that ringing because this whole thing appears to be ringing. So let's turn this on, and I'm going to move this back so you can see the whole thing. I can only move it back so far. So this is with it just floating there. It fell off, so it's not touching anything. This is with me touching it, so I provide a lot more energy to it. So this is me touching it. We're at 1, 2, 3, plus 0.3, and 1, 2, like minus 0.3. So like 0.6 volt oscillation. So it's kind of hard because me touching it affects it. That's me touching the capacitor on the positive lead even though it's been discharged, tapping it. That's me touching the primary coil. All right, let's see if we can just get it to stay on the primary coil like this, and then just ground, literally on the ground. So now we're at 0.1 volts per division. Let's turn this on. No flash this time. And then got an orange type glow, and it seems to be kind of bogged down as of right now. Here's our spike. Kind of interesting. So that's half a volt per division. You can't really see it, but there's a vertical spike really going up with every single one of those off the screen. Super high multi-frequency, obviously. It doesn't appear like that when it stacks with the aliasing. So let's go to, we're at 5 volts per division. So we have vertical peaks at 5, 10, 15 volts going up. So that'd be a pretty good charger for a battery. Good job, K Energy. Alright, let's see if I can pull that off. Whoa. It's really picking up. Oh. I just turned the resistance all the way up. So it's really going high frequency now. And we see at 2 volts per division, it's like really negatively biased now. But Okay, there's half a volt per division. And let's give it more power so you can see that kind of interesting waveform. So that's 0.1 divisions per frame. We're getting some aliasing effect. You can really see the peaks at 2 microseconds. Kind of interesting. Oh, it just picked up again. Changed frequency. Neon bulb is really going. There's 0.2 milliseconds time sweep. Now we're at 1 volts per division. So let's touch something else. So as you can see, now I'm touching this and you're not reading anything. Now I'm touching the metal and you do. So it picks up like the scalar energy of my body because I'm made out of water. Oh, that's a cool waveform. So this is my body, 0.2 volts per division. We're getting a negative voltage bias out of my body. Well, that's a 50 millivolt signal coming out of my body right now. It's 0.1 volts per division out of my body. As you can see, that's 0.2 millisecond time sweep. So it's really high frequency noise, as you can see. Whoa. Kind of weird. Just pure white noise coming out of this right here when we go at a really small time scale. That's really small time scale. That's 2 volts per division, and we're like really down there. It's kind of weird. So now that's a slower time scale at 5 millisecond pulse. Seems to be kind of somewhat steady. All right, let's touch something else here. Put it back on here if I can. So you have to go to a smaller signal with this to around 20 millivolts. So that's 0.1 volts, or like 0.1 milliseconds for your time sweep. You can kind of see it modulate there. Go forward. Go backwards maybe. Maybe I can control it with my mind. Go back. Now go forwards. No? Okay. Well, I thought it was messing with my mind. Haha. Okay, it decides when, I guess. So what if I touch this ground again? Really bogs down. I get this signal. Pull it off. Get that signal. That thing's pretty zipping. So I wonder, if I can just spark gap this, like, just... Ah. Still getting some ringing. Alright, motor is just about stopped. And it seems to be ringing just the same. So I wonder, this is decoupled to this. If I touch this, does it affect that? Touch. Oh, you see that's downward spike? That was weird. Touch, touch. Huh. There was a couple downward spikes when I touched it there for a second. But it seems to be like unaffected here when I touch it. Like I can touch the iron core. Now if I touch what we're measuring, does that change it? Probably. So I'll just touch the ground. Yep. Touch the ground, not touch the ground. Now I'll touch the positive lead. Whoa. Yeah. So we're definitely decoupled here with our system, which is good. So now let's see if we can get a good spark right here. That always scares me. That didn't actually shock me. All right, this time I'll see if I can fry this LED for you guys. So I think this side's positive. Try this again. So only one side seems to be charging, which is interesting. I don't know if it's just not getting good contact or